Okay, we have another integral problem here. The integral of 1 over the square root of the quantity 1 minus x squared dx. And you can look through here and play around with different methods of integration by parts, integration by substitution. But what you should want to do is just to get all that to go away. One way to do that is to pick a clever and useful trigonometric identity for x. So I'm going to propose using x equals sine theta. So wherever we see an x in here, we can replace it with the sine of theta. The dx is coming along for the ride because I realize I've changed variables, but I haven't found out what precisely dx is equal to, so I'm just going to leave it alone for the moment. 1 minus the quantity sine theta squared is equal to 1 minus sine squared theta. 1 minus sine squared theta is a trigonometric identity that you should know. It's cosine squared of theta. The square root of cosine squared theta is just cosine theta. And now I've got to deal with this dx bit. Well, I see that I have x. I need to find its derivative, because I'm looking for a dx, so I've got to get a derivative going on in here somewhere. So I'm going to differentiate x with respect to theta. So that will leave me with dx d theta. Equals cosine theta, but I need to find dx, and I don't have that. I have dx d theta. So I'm going to separate dx d theta by moving d theta to the other side. And now I know that dx is precisely equal to cosine theta d theta, and that means I can substitute it here. Which is going to leave me with the integral of cosine theta divided by cosine theta, all that times d theta. Cosine divided by cosine is 1. So before I even do any of the calculus bit here, I'm just going to have the integral of 1 d theta, or the integral of d theta. Since there's the implied 1 here, that's going to be a constant integrated with respect to some variable, and that's just going to be that variable plus some arbitrary constant c. And we're almost done, but not quite, because we started off with something with an integral with respect to x, and we're winding up with an answer in terms of theta. So that means we've got to go back to our original variable, and I'm just going to do it right here in the middle here. So we're going to get the answer to this from the equality we wrote, where we said what, when we changed x, we said what it was equal to. X is equal to the sine of theta. To find out what theta is equal, so we can replace it back in terms of x, you'll take the inverse sine of both sides. So that's going to be theta equals the inverse sine of x. And I will have to replace this here for the answer to make sense in terms of x, because that's what we started with. And